So this is about to be the end of section 5.1. It's actually my third attempt this morning at doing these last few problems. They shouldn't be particularly hard. I keep tweaking my instructions because my instructions started out being so complex that they really weren't understandable. So and now they're this. So each of the problems between 17 and 26 ask me to form a polynomial whose x-intercepts are given. And when I look at the problem, I'll see a few x-intercepts and something about the degree. The degree of a polynomial is its highest exponent. And so what problem 18 wants me to do is it wants me to create a polynomial whose highest exponent on the x is 2. So I'm going to create a function or a polynomial. The function will be a polynomial that has x squared for the highest power of x. It may have a number in front of the x, but it probably won't. Some of the problems it will, but this won't. So this problem, number 18, wants me to create a function that's a polynomial. It has degree 2, which means the highest x power term is an x squared. It may or may not have a number in front of it. It may have a coefficient, but most of the times it won't. That has x-intercepts of -2, 0, and +4, 0. This is kind of working backwards. This is giving me an x-intercept, and I have to create a factor that generates that x-intercept. So my first step is create the factors that give the x-intercepts and this is kind of just working backwards. The algebra that would produce these x-intercepts, the last step of the algebra would give me x equal to -2. And when I'm going to find an x-intercept, if the algebra gave me x equal -2, I'd say the x-intercept was -2, 0. Similarly, the algebra that would give me an x-intercept of 4, 0, would have x equal to 4. Of course, we create x-intercepts by taking factors and setting them equal to 0. This would be the result of setting a factor equal to 0, but it doesn't show me the factor that gave that x-intercept. So second, I'm going to set make each equation equal to 0. For the left equation, I'd add 2 from both sides and get x plus 2 equal to 0. This is going to be one of the 2 factors that I need for my answer, because if I had the equation x plus 2 equal to 0, if I had a factor of x plus 2 and I set it equal to 0, the algebra that I would do with it is I'd minus 2 from both sides. I'd get x equal to -2. I'd say there's an x-intercept of -2, 0. For the x equal 4 factor, the x equal 4 equation, that answer would come from the factor of x minus 4. If I had the factor of x minus 4 and set it equal to 0, the algebra would give me the x-intercept of x equal to 4. So these are the two factors that make the x-intercepts. Step 3, I'm going to multiply the factors out. I'm going to call them factors because they're going to turn into factors. So my function, I'm going to say, is f of x equals to x plus 2 times x minus 4. Because if I asked you to find the x-intercept of this function, you'd go x plus 2 equal to 0, x minus 4 equal to 0. Setting the x plus 2 equal to 0, the algebra would give you x equal negative 2, and you'd say the x-intercept is negative 2, 0. Setting x minus 4 equal to 0, the algebra would give you x equal to 4, you'd say the x-intercept is 4, 0. The instructions say to multiply out my polynomial, so I'm going to do that. I'm going to FOIL this. My firsts are going to be x times x, which is x squared. My outers are x times minus 4, which is minus 4x. My inners are positive 2 times x, which is 2x. My lasts are 2 times negative 4, which is negative 8. I'm going to combine my outers and inners, and I'm going to get an answer to number 2, 18. The polynomial of degree 2 that has x-intercepts negative 2, 0, and 4, 0 is going to be f of x equals, and then I'm going to get x squared. Those inners and outers combined to be a minus 2x minus 8. Just in case that's not readable, it's x squared minus 2x minus 8 equals f of x. And let me check this. First of all, it fits that I have a polynomial of degree 2. Does it have the x-intercepts of negative 2, 0 and positive 4, 0? Easy enough to see. I can just turn my equation on and graph the function x squared minus 2x minus 8, do zoom standard. That looks like an x-intercept of negative 2, 0. That looks like an x-intercept of 4, 0. To make sure those are the x-intercepts, I'm going to go second and graph and hit the table, and I'll arrow around. I'll make sure that next to negative 2 in the x column, there's a 0 in the y column. So there's the point negative 2, 0, which is one of the two x-intercepts. And if I arrow down some more, I see next to 4 in the x column, I see 0. So the x-intercepts of this are table-wise, negative 2, 0, and 4, 0. Graphing-wise, the point negative 2 and positive 4, 0. My answer is perfectly correct. So for each of the problems between 17 and 26, we're just going to follow these steps. We're going to create, for every x-intercept, we're going to create a factor by setting the x part of the x-intercept equal to x and then setting that equal to 0. You're going to get multiple factors, and you're just going to multiply the multiple factors out to get your answer. Okay, there's very likely a glitch in the video. I started watching my videos that I recorded earlier this semester, and the camera started making little waves in the videos. I'm trying to cut all those out. I'm sure as you watch videos later in the semester, you're going to see some of those waves that I missed. So problem 20 is a lot like problem 18. It asks me to create a function that has degree 2. So I know in my answer, I'm going to have an f of x equals to x squared to have a degree 2 polynomial. In this problem, because one of the intercepts is a fraction, I'm going to wind up having a number in front of that x squared that I didn't in the last problem. So let me try to get my answer. I start all these problems by making x equal to each one of the x coordinates of the x-intercepts. In this problem, I have two x-intercepts. I'm going to set x equal to 4 and x equal to 2/3. And then I'm going to make each one of those equal to 0. For the x equal to 4, I could set it equal to 0 just by minusing 4 from both sides. For the x equal to 2/3, I need to multiply both sides by 3 to get it set equal to 0. On the left-hand side, when I multiply by 3, I get 3x. On the right-hand side, when I'm multiplying 2/3 times 3, you can really just cancel the 2 with the 3. Another way to multiply 2/3 times 3 is to think of the 3 as a fraction 3 over 1. And then you can go multiply 2 times 3 and get 6, 3 times 1 and get 3. This would give me 6 over 3, which is 2. Regardless of how you simplify the right-hand side, whether you do something like this, or if you just cross out the denominator with the 3, the right-hand side should have a 2. Now I'm going to minus 2 from both sides and get 3x minus 2 equal to 0. So the function that I need to create is going to be the product of x minus 4 and 3x minus 2. I'm just going to FOIL to get my answer. The first are going to be x times 3x, which is 3x squared. The outers are going to be x times minus 2, which is minus 2x. The inners are minus 4 times 3x, which is minus 12x. And the last are minus 4 times minus 2, which is positive 8. This is going to give me, if I simplify this, 3x squared. Those terms combine to be minus 14x. Both the numbers in front of the x's are negative, so I add them and keep them negative, and I bring down the plus 8. So easy to check these that I'm going to check them. I'm going to graph this function and make sure it has these two x-intercepts. And let me do that real quickly here. So let me graph the function y equals 3x squared minus 14x plus 8. I'll graph it. It needs to have an x-intercept of 2/3 and 4. I think that's the x-intercept at 2/3. I believe that's the x-intercept at 4. A real slick way to check that these are actually the right x-intercepts is to do this. Hit your second button, and then the trace key. Hit enter on value. I'm going to type x equal to 2/3, going 2 divided by 3. When I hit equals, it's going to give me the y-coordinate of the point that has an x equal to 2/3. When I hit equals, if I get 0, then that point right there is the point 2/3, 0, and I feel good about that part of my answer. It did, so I feel good about that. I'm going to check this point right here by going second calc, hitting enter on value. I'm going to type the number 4, and after I hit enter, if it comes back with a 0, then I know I have this point right as well, because I'm finding, when I do this computation, the y-coordinate of the point that has x equal to 4, and when I hit enter, I get 0 again. So I'm bang on, I know that answer is right. So give 19 a go. 21 and 22 are not quite as nice. They're third degree polynomial. Let me just be nice and do your problem 21, specifically because on a test I don't think I ask for a third degree polynomial. So let me work on 21. I'm going to come up with an equation that's a third degree polynomial. So in my answer to problem 21, there's going to be an x cubed. Because there's a fraction for one of the x-intercepts, the denominator of the fraction is going to wind up being in front of that x cubed, but I don't need to know that ahead of time. I'm going to get started by setting 3 equations, one for each degree. So I'm going to set x equal to the x-coordinate of the first point, x equal to the x-coordinate of the second point, and x equal to the x-coordinate of the third x-intercept or third point. For this one, I'm going to add 3 to both sides and get x plus 3 equal to 0. For the next one, I'm going to multiply both sides by 4. When you multiply 3/4 times 4, you can just multiply 3/4 by 4 over 1 because 4 is the same as 4 over 1. You can multiply 3 times 4 is 12. 4 times 1 is 4, multiplying across the numerators and the denominators. And then 12 over 4 is 3. The right-hand side is going to come out to be 3. The easier way to do it, anytime you're multiplying a fraction by an integer, you can just cancel the denominator with that fraction, if it's cancelable. And this gives me 4x equal to 3. I'm going to minus 3 from both sides and get 4x minus 3 equal to 0. And then this one, when you set it equal to 0, you minus 3 from both sides and you get x minus 3 equal to 0. The function that I need to create, I need to multiply these 3 factors together. It turns out if you make this factor last, it will make the multiplication a lot easier than if you put this factor in the middle. You can put these factors in any order that you want, And if you've done enough of these, you'd realize that that 4x minus 3, putting it first or second, is going to make more work for you than making it last. So now I'm going to start working this. I'm going to FOIL these two. And then after I FOIL those two, I'm going to worry about the 4x minus 3. So those I can FOIL in my head, but I'm going to do it by hand. So first are x times x, x squared. Outers are x times minus 3, which is minus 3x. Inners are positive 3 times x, which is positive 3x. Last are positive 3 times negative 3, which is negative 9. The 3x's cancel, and you get x squared minus 9. One more stage of multiplying out. I'm going to go firsts, x squared times 4x. The 4 is just going to hang out there, and I'm going to multiply an x squared and an x and get an x cubed. So that first is going to give me a 4x cubed. Outers are x squared times minus 3, which is a minus 3x squared. Inners are minus 9 times 4x, which is a minus 36x. And last are minus 9 times minus 3, which is a plus 27. Just about have my answer. The first term in my answer is going to be the 4x cubed. The second term in my answer is going to be, oh, those don't even combine. My second term in my answer is going to be minus 3x squared. Third term in my answer is minus 36x. Fourth term in my answer is plus 27. I actually did have an answer there. I was getting ready to combine these, but they didn't combine because they don't have the same exponents. They're not considered like terms. So I think this is my answer to 21. Absolutely should check. I'm going to graph this function and make sure it has x-intercepts of negative 3, positive 3/4, and positive 3 by using the second calc value feature. So on my calculator, I'm going to graph the function 4x up arrow 3 minus 3x squared minus 36x plus 27. When I graph it, I don't need to see the maximum and minimum turning points. I just need to see the x-intercepts. So I'm not going to play with my window at all. When I sketch a graph, it's probably going to shoot off the screen quite a bit, but that doesn't bother me. I just need to be able to make sure that I have an x-intercept at negative 3, positive 3/4, and at positive 3. To check that I have an x-intercept of negative 3, I go second in calc, hit enter on value. I type the number negative 3, and when I hit enter, it has to come back with 0. If it comes back with 0, then that is the x-intercept of negative 3, 0. I hit enter, and it does. For the next one, I'm going to go second calc, hit enter on value, type 3 divided by 4, which is that x-intercept. If when I hit enter, it comes back with a 0, that is a 0.340, which it did. And lastly, second calc value, type x equal to 3, better come back with 0. If each time I check an x-intercept by doing second calc value, by entering the x, if I get a 0 back for the y, then that graph has that x-intercept. All right, so I'm not going to do 22, but I will do 24, and I'll let you do 23. So 24, I need x-intercepts of x equals square root of 3, and x equal negative square root of 3, and I'm coming up with a second degree polynomial. So my answer to problem 24 has to have an x squared. Since none of the x-intercepts are fractions, there's probably not going to be a number in front of the x squared. I'm going to set each of these equal to 0, just like I've done in the last few problems. This is going to give me x minus square root of 3 equal to 0. This one I'm going to add square root of 3 to both sides and get x plus square root of 3 equal to 0. The function that I need to create is going to be the product of x minus square root of 3 times x plus square root of 3. I'm going to FOIL this to get my answer. The firsts are going to be x times x, which is x squared. The outers are going to be positive x times positive square root of 3. That's going to be positive x square root of 3. The inners are going to be minus square root of 3 times x. That's going to be either minus square root of 3 times x or minus x square root of 3. I could have written this as a square root of 3 times x and minus square root of 3 times x. I probably should have written the x second, but I didn't. The reason I didn't write it second because I was afraid the x was going to look like it was under the radical, and it's not supposed to be under the radical. If you write it after the radical, the radical sign can't have the x under it. The lasts are going to be negative square root of 3 times positive square root of 3. That's going to be negative square root of 9. When I go to simplify this, the outers and the inners cancel. The x squared comes down, and the square root of 9 turns into a 3. So my answer is going to be x squared minus 3. Let me check this real quickly to make sure I'm right by graphing the function y equals x squared minus 3. Graph it. I don't really need to see the vertex, but I can. Now I'm going to go second calc value, type in second square root of 3. For this to be a correct x-intercept, when I hit enter, it has to give me 0, which it did. And now I'm going to do this one, second calc value negative second square root of 3. And then when I hit enter, it gives me a 0, so I know my answer is correct. So your problem 23 works the same way. My problem 26 is not so pleasant. It wants a degree 3 polynomial. Even though two of the intercepts are square roots, none of them are fractions, my answer won't have a number in front of the square root, or in front of the x cubed. In problem 26, when I go for my answer, I'm asked to create a third degree polynomial, so my answer is going to have an x cubed in it, and it's not going to have a number in front of the x cubed because none of the x-intercepts are fractions. To get what I need to multiply together, I'm going to set x equal to the square root of 3, x equal to the minus square root of 3, and x equal to 7. I'm going to minus square root of 3 from both sides here and get x minus the square root of 3 equals to 0. I'm going to add square root of 3 to both sides here and get x plus square root of 3 equal to 0. And I'm going to minus 7 from both sides here and get x minus 7 equal to 0. The function I need to create is the product of x minus square root of 3 times x plus square root of 3 times x minus 7. I very specifically, in your problem 25, made you have the positive and negative square root of 2 in problems 23 and 25. And I made my problem 26 and 24 had the square root of 3 and negative square root of 3. This is because the first thing I did, or one of the things I did in problem 24 is multiply that, and that came out to be x squared minus 3. Well, the first multiplication I need to do right now is I need to multiply x minus square root of 3 times x plus square root of 3, and I know that x minus square root of 3 times x plus square root of 3 equals x squared minus 3. The reason I put these problems one after another is to skip the need for doing that multiplication again. So the multiplication that I just highlighted, I'm going to write x squared minus 3 in place of it, and I'm not even going to FOIL it out again because I just did that exact multiplication. It's going to come out exactly to the same x squared minus 3. Now I'm going to continue FOILing by going first x squared times x, and that's going to be this x cubed, and then x squared times minus 7. That's going to be minus 7x squared. That's the outers. The inners are going to be minus 3 times x. That's going to be a minus 3x. My lasts are going to be minus 3 times minus 7, which is a plus 21. I claim that this is my answer to problem 26. Let me graph it and make sure that each one of these is an x-intercept. So y equals clear x up arrow 3 minus 7x squared minus 3x plus 21, graph it. I don't need to see anything but x-intercepts. Let me make sure that this right there is that x-intercept by going second calc value negative second square root of 3. I'm checking this one right now. When I hit enter, I better see 0, which I do, so that one's good. Now let me check this one. That's actually that one there. Let me check that one next by going second calc value second square root of 3, And when I hit enter, if I get 0, I feel good about that one, so that one's there. Last one, second calc, value, type 7, and I get 0. So I've checked to make sure all 3 of those are actually x-intercepts. I know my answer is correct. So now we're done with the section. It was monstrously long, so why don't you give problem 25 a go and then shut this thing down.